So p cubed wants to know the weight of the heaviest item and the weight of the lightest item. An operator enters weights for each item. The operator enters 0 when finished. The algorithm will take the weights of an item in, count the number of items, tell the user if they have entered an invalid weight, output the weight of the heaviest item, and output the weight of the lightest item. And here we have a sample output. So enter the weight for the item, 0 to quit, 800. Enter the weight for the item 0 to quit, -123. Error message was displayed, no negatives allowed. Enter the weight for the item 0 to quit, 500. Enter the weight for the item 0 to quit. Enter the weight for the item 0 to quit, 0. Write an algorithm to meet the requirements. Use pseudocode or a programming language with which you are familiar. There are 9 marks. Do not draw a flowchart. You will not get any marks for drawing a flowchart on this question. So rather than just showing you some pseudocode, I want to show you how to perhaps you might approach this in order that you can pick up some marks. There's 9 marks available for this. So I think that one of the ways you could approach this is having got these bullet points, these requirements here, to turn these requirements into pseudocode and use the sample outputs for some help as well. So first one here is take the weights of an item from a user. So we would be going to send, enter the weight for the item to display, and then we would be receiving, so receive, come up with your relevant variable name, receive item weight from keyboard. Data type, well, all of the examples are integers, so it could be an integer, it could be a real if it's less, if it's got a half in it. We're not actually doing any maths with it, so it could be a string. I'm going to go string because then I'm going to, but it could be either an integer, real or string, I think, in this case. So we're going to count the number of items, which means we need to set up a variable to store our count to 0. So remember, in our flowchart we set up our variables at the beginning and did our inputs, and we're also going to need to store the heavy item, so we could set heavy item to 0 as well, and we need to store the lightest item, so we can set light item to not 0, is it, because if 0 is already lightest you're going to get, so we need to set it to a big number, so I'll just go for 10,000. So that's my so some initial variables set up. And we've got this section here, tell the user if they have entered an invalid weight, and the information on the output, the picture down here, is no negatives allowed, so that's how we know it's invalid. So if item weight is less than 0, send error, no negatives allowed to display. And we'll do an output statement down here as well, because we've got some send, so we can go send the weight of the heaviest item is, and heavy item to display, and do the same for the light item, so send the weight of the lightest item is, and light item to display. Okay, so I think that's pseudocode now on all of those requirements in the bullet points. Now let's see what else we're going to need to do. We have taken that in, counting. Well, we've set up a variable to count, to store the count, but nowhere have we started to think about actually counting. So at some point in the program we are going to have to add to our counter. So count equals count at +1. At some point, this is out of sequence at the moment, but at some point we will need to do that. And that's the same with the weight of the heaviest and the lightest items. We've set up variables to hold them, but as yet we've not thought about how we are going to be setting them up. So if the item weight is greater than the heavy weight, then do is the better. I didn't do that before, I used a colon, but if heavy item weight is greater, then do, we would go set heavy weight to item weight, and we'll do the same with the lightest weight. So if item weight is less than lightweight, then do, and we'll set lightweight to item weight. Okay, so we've set those up now. And then we need to read the question again, because we need to work out what else we're missing. And I genuinely think that you'll be asked for for iteration, so some kind of loop and selection in these, and you need to look for those. So we have some selection, we've got some ifs here, and we've got some variables, but we don't have any iteration at the moment. So I'm going to look for that. So we enter the weight, the operator enters 0 when finished. So this is our iteration. So when finished, so they're going to keep entering items until they enter 0. So until should give you the clue that this is going to be a while loop. So it's until they enter 0. 0 is would be entered here at item weight. So our while loop would be repeat, something like repeat until item weight is equal to 0. So we've got a while loop, and we're going to need to put it all together now. We've got a loop, we've got our inputs, we've got our counter, we're using our counts, we've got that, we're setting that up. I think we're ready to put it in order. Right, so I've moved the code down here now, my pseudocode. You obviously wouldn't be able to just copy and paste and bring it down like that. You'd have to maybe start to write 1, 2, 3 and that kind of thing to put it in some sort of order. So, beginning of an algorithm, we initialize our variables. We don't want to have our variables inside a loop, otherwise they'll keep getting reset. So we'll initialize our variables. Then we need to think about our loop. Well, if this is item weight is actually our condition, so that's going to have to go there like so. And then we can start inside our while loop. What are we going to do? Well, the first thing is we're going to check that it is valid. Okay, so we'll check that that is valid. So if the item weight is less than 0, the error will occur. If it's not, so that will be an else. Now we don't have an else, so let's we'll have to add that now. Else we can count. We can add 1 to count because it's passed the test, it's valid, so we can count it. Now we can do our checks for whether or not we can for heaviness. We should of course have end ifs in place for pseudocode. So maybe when you're writing it out that you leave yourself some space so that you can add this. And remember to use the pseudocode booklet that's at the back of your paper. And we need to have an end while for our repeat until. So we also need to, once we've entered an item and it's passed, it's been counted, it's been checked, well then we're going to need to ask this question again. So that, because this will go here, and if it is, if it's not 0, then it will loop back round. If it is 0, then we will have an end while loop. And finally at the bottom where our outputs, so we know that's where they're going to go, so that's where we've put them. So that's my algorithm, my pseudocode for that question. What I was there'll be different answers of course, but what I wanted to show you was how to approach this by breaking it down step by step and by using the information that's provided for you and looking for the clues and then structuring it, and we'll have a look at the mark scheme. So here is an example from the mark scheme, which you're welcome to pause and have a look at. I think that doesn't look too dissimilar to the one that we just did, although I've got too many end ifs, although I dare say that's not going to make massive difference to the marks. So have a pause of that and have a look and make sure that you understand the logic of that. It is the same logic that we've just talked through. So finally, let's look at how those 9 marks are awarded. 3 marks for functionality, 3 marks for accuracy of your notation, your pseudocode, and 3 marks for the efficiency, appropriateness, and accuracy of your solution. So lots to play for here. Do nothing, get nothing, but I hope now that you won't do that and you'll have a plan of how to approach this. Illogical solution that wouldn't work would still get you a mark. So if you did what I suggest, which is go through the bullet points or the requirements of the task and set out some lines of code, put them in some kind of order, you would get a mark. No use of Python or pseudocode, maybe you've just written it in English, may still get you a mark, and some significant errors. So if you just did those bullet points, we didn't at that point have a while loop, for example, you'd probably get, but that could be 3 marks, which is half a grade boundary. So you need to be going for that, and then of course going up, so until you get to the full correct solution with excellent pseudocode and a good logical solution. So really well worth going for that question, and use your pseudocode booklet.